My name is John Melvin. Imagine a future where you could put your head onto a robotic body. How awesome would that be? Well, it might sound a little far-fetched, but we're actually a lot closer to that possibility than you think. In January of this year, Dr. Sergio Canavera, world-renowned Italian neurosurgeon, announced his full intention to do the world's first body transplant. The volunteer, a man named Valery Spirnidov, crippled with muscular dystrophy, he's been unable to walk and needs assistance in every aspect of your life. He hates it, and he's looking forward to the opportunity to be able to live on his own and live his own life and be his own man. Dr. Canavera is accompanied by a team of over 150 different doctors and nurses, including Dr. Zhao Ping of China. According to BBC.org, Dr. Zhao Ping has been recruited because of his shared interest and enthusiasm not only for neurosurgery, but the potential of this procedure working. According to news.nationalpost.com, Dr. Canavera has been advocating the possibility of this procedure for over 30 years. That means in the 1980s, he was going around talking about the potential of this procedure being done. But it's just because of new fruitations and advances in medical technology that it is now possible for him to do. Now, you might be wondering how this procedure would work. It's incredibly complicated, but we can simplify it down a little bit so we can all understand it. First, they intend to cool the body down to about 15 degrees Celsius. Doing that will increase the tissue longevity, increasing how long the tissues can last without oxygen. Then, they plan to scrape away all of the flesh in the neck area, leaving only the blood vessels and the spinal cord itself. Then, acting quickly, they plan to clamp, sever, and then reattach the tubing and all the blood vessels in his neck to the other body. After they've done this, they're doing the final step of the procedure. Using a $250,000 diamond nanoblade that's transparent, they plan to, in one swift motion, sever the spinal cord, lift the head up using a crane, put it next to the other body, and then reattach it using a sort of neural glue. This glue not only helps the spinal fibers latch together, but also grow back together and create new connections. This could enable him to walk, move, run, and do all the things that we do today with somebody else's body. That's amazing. Now, it seems kind of scary, but he likens it to the first steps of the first cosmonauts, the first humans to step foot into space, out of this Earth's atmosphere. According to The Atlantic, Valery Spirnidov said, "Removing all the sick parts but the head would do a great job in my case. I couldn't see any other way to treat myself." So, regardless of feelings of critics around the world, all of the people involved in this procedure are enthusiastic about it, and Dr. Canavera actually predicts about a 90% success rate. That's just amazing. Now, there are a lot of potential complications with this procedure, including the risk of infection or immunorejection on the part of Valerie's head to the new body. There's a chance that the body and the head won't have the same sort of immune systems and the same proteins in the blood and could actually reject each other. To help prevent this, they're going to put him in a medically induced coma for about a month and a half to hopefully promote the regrowth of the neurons without his immune system attacking the body. The basis for this experiment, or this procedure, comes from 3 different experiments that they've done with animals in the past. The first involved decapitating a rheus monkey and successfully reattaching all of the blood vessels and tubing to the body of another rheus monkey. This monkey was kept alive for about 9 days, and it had full circulation and was alive. The second experiment was done on a dog. The spinal cord of this dog had been severed about 90% of the way through, and using the neural glue mentioned before, they were able to completely repair the spinal cord and in the end obtain full mobility after about 4 months of therapy. They then repeated this experiment with laboratory mice. In an interview with the head researcher of this project, according to telegraph.co.uk, 100% mobility was achieved in the paralyzed mice. This means that based on animals with similar biology to our own, it's entirely possible that this procedure will work, and all involved are incredibly optimistic. Now, it's a complicated moral issue, but within just a couple years, the possibility of a future where we can all have robotic bodies and yet keep our own heads, our own identities, and our own thoughts is within our grasp. Thank you.